Hello viewers, you're welcome back. This video we'll be looking at 6.4. So we'll start with the graph of cosec and the graph of sec. Now the first example here says we should sketch the graph of one period of cosec x. Now what we're going to do, we will start with one period of the graph of sine x. So this is what we call the helper graph. So for sine of x, we know how it is. We know the period is from 0 to 2 pi. So sine and cosec, they have the same period. So this is, which is the period of 0 to 2 pi. And how do we sketch the graph? We divided this period into, so we know the period is 2 pi, right? This is the period of sine x. So here it's going to be pi, and here it's pi over 2, and this is 3 pi over 2. The maximum value is going to be 1, the minimum is -1. Right, so at x is equals to 0, sine x is also 0, so we are here. And then x is equals to pi over 2. It's going to be here at x is equals to pi. We're back to 0. At x is equals to 3 pi over 2. We're back to the minimum. And at 2 pi, we're back to 0, which is the baseline. So this is going to be this one. So this is the graph of sine x, but we are not interested in the graph of sine x, but the graph of what? Cosec x. But what is cosec x? We know that cosec x is the same thing as 1 over sine x. So it means you have a vertical asymptote. Where's the vertical asymptote? When sine x is equals to 0, right? So it means that what? Anywhere sine x is 0, you have a vertical asymptote at that point. In other words, the x-intercept of the graph of sine x, because these are the x-intercepts. So it means you have a vertical asymptote here. And also at pi, you have a vertical asymptote, because these are the zeros of the graph of sine. Right. So now for the graph that we're interested in, we're interested in which graph? In the graph of cosec x. So what do? You just flip this one. Remember, this is going to be -1. So you flip this like this. And you know you have a vertical asymptote here, so you cannot cross it. And here also, it's like rotating it about this point. Now, so the purple graph or the purple curve is the graph of what? Of cosec x. But this is just one period, so you can draw more than one period of it, right? And here we should also know that if sine x is equals to 0, it means that x is equals to what? N pi, where n is what? Is an integer. So this will give you all the vertical asymptotes. But here we have only how many vertical asymptotes? I think we're taking only 3. Because if n is 0, you'll get 0. If n is 1, you'll get pi. And if n is 2, you get 2 pi. So we don't even need to bother about this one. Once we plot the graph of sine x, the x-intercept will be the vertical asymptote for the graph of cosec x. So now we can decide to what? We can decide to remove what? We can decide to remove this one because this is not what we need actually. So we can remove the black one and then we just leave this one. So this is the graph of cosec, the purple one. All right. Then for number 2, is, okay, let me just leave this one, but let me use, let me just use dotted lines. Yes. Now, for example number 2, it's similar, but here we want to sketch one period of what's of secx. So we're going to start with what? Since we know that secx is equals to 1 over cosine x, so we will start with our helper, which is now the graph of what? Cosine x. For the graph of cosine x, we know that the period is still 2 pi, and the amplitude is still 1 in this case. So it's 1, which is similar here. Also in the first example here, we should talk the amplitude is still 1 here. All right, so what do? We try to sketch also just one period of cosine, which begins from, we'll start from 0 to 2 pi as well. And then we split this into 4 intervals. This will be pi over 2, and this is 3 pi over 2. So the maximum is going to be 1, the minimum is -1. So this is the graph of cosine. At 0, we will start from where? At 0, we will start from 1. And then we're back to pi over 2, it will be back to the baseline. If you move forward, we will go to the minimum. And if we move one step forward, we will come back to the baseline. And then at 2 pi, we are back to the maximum. So this is the graph of sine x, which is same as what we saw in 6.3. All right, so now we know that the zeros, what are the zeros of cosine? It means the x-intercept. So these are the x-intercept. So this will be our vertical what? Asymptotes. So we have 2 vertical asymptotes. Now, what we can do, if you look at this, remember we need only one period, so this is enough. But this one, let's assume we want to continue. If I continue this graph, it's supposed to come down up to this point, right? And this one also is supposed to curve up to this, back to the baseline, yes? So this is to help us see how the rotation will be, right? So you can see now that you have a full curve. Since we have a full curve, this is just going to be just this one here, the purple one, very close to the asymptote. Here also is going to be just a full like this. Right. Then here as well, it's supposed to be like this, full one. Right. But you can see that this part, I just completed this one just for us to be able to see how it's going to look like. So, but this part is not part of the business. So I have to remove this part here because we need only one period. So which means that we should also remove this other part. So we will have just this part left here. If you come back here also, you will see that this additional part, I just added it. It's not part of one period because the period will stop at 2 pi. So it means we will remove this part here. We can remove it. And once we remove it, we have to remove this up also. So it will just be like this one. Okay. So this is the graph of what's of cosec x, the purple one, right? So the black one, which is our helper graph, let me just remove it now and just use dotted line. So something like this, something like this. Okay, so the purple one is the graph of what? Of cosec x. And if you like, the graph of sec x. If you like, you can remove this helper graph completely. There's no big deal about it. You can remove it. All right. So now let's see a little bit of transformations. Transformation, when we have transformation, how can we plot the graph? So let's look at example 3. I think we can still have this here. For example 3, we want to sketch the graph of cos minus cosec. So we will start with the helper. And what is the helper in this case? Is minus sine x plus pi over 2, right? So this, we can find the amplitude is absolute value of minus 1, right? Which is just 1. And the period is 2 pi over what? Over k, which is just 2 pi. K here is 1. So this is still 2 pi over 1. And also you have a horizontal ascent shift, which is x is equals to minus b over k. And that will be x is equals to minus b is what? B is pi over 2. So pi over 2. Now, how am I getting this? Remember, you just need to compare with a sine what? Ax plus b plus c, right? So it means k is 1, c is 0. So this is, and b is pi over 2. So x is equals to pi over 2 is the horizontal shift. And this means that the graph is shifted to the what? This is going to be to the left. Yeah? All right, so now to know our interval, just like we did before using this method, our interval originally is supposed to be from 0 to where? It's supposed to be from 0 to 2 pi, right? But now you can see there is a shift to the left. So you have to shift each point to the left, right? So let's split this into 4. Let's see. This is pi. This is what? Minus pi. No, this is pi over 2. And this is what? 3 pi over 2, right? Now, because we have a horizontal shift of minus pi over 2, it means you have to remove minus pi over 2 from each interval, right? From each point here. And once we're able to achieve that, then we will have the interval to work with. So let's say we have this interval now. So the first interval, if you do 0 minus pi over 2, is just going to be minus pi over 2. This is where we'll start from now. Then pi over 2 minus pi over 2, this will be 0. Pi minus pi over 2, this will be pi over 2. 3 pi over 2 minus pi over 2 is just going to be pi, right? And then 2 pi minus pi over 2, this will be 3 pi over 2. So this is what we need. And our A is still 1, and the maximum is 1 and minus 1. So to graph this sine, this is sine. We know sine, we should start from where? We should start from the baseline, from the beginning. So we have sine of minus pi over 2 is going to be 0. We're going to start from 0. Yes, this line. So this is going to be 0 here. Then sine 0, now we have to go to the maximum, which is, okay, now let me stop here. Instead of going to the maximum, we go to the minimum because you have a minus here. This is a reflection, right? So because of this reflection, instead of going to the maximum, we will go to the minimum. So it means from the baseline, we will now go to the minimum. Then now we're back to the baseline. Then we go to the maximum. Then we're back to the baseline. So the graph is going to be something like this. Right. So this is the graph of what? This is the graph of minus sine x plus what? Plus pi over 2. Right. And here, all you need to do, just pick the zeros. The x-intercept will be the what? These are our vertical asymptotes. So these will be the vertical asymptotes. Okay. So these are the vertical asymptotes, right? Then now that we have the vertical asymptote, we just need to reflect. This is going to be something like this. This one. And then you have this up here. All right. So one thing I would like to mention here is the question is asking for where it is what? Increasing and where it is what? Decreasing, right? So let me just do a lot of, so let's look at it now. Increasing, remember our focus is on where? On the purple curve. So not the black, right? So if you look at increasing, it means you are increasing here, this point, from here to here. So this is going to be from minus pi over 2 to what? To 0 open, union. You also have another increase in this part here, which is from pi to 3 pi over 2, right? See that? That is increasing. Now decreasing, decreasing is what? Is from here, which is going to be from 0 to pi over 2, union. Here is also another decreasing, which is from pi over 2. Remember, when you are looking at increasing and decreasing, we're interested in the values of x. Okay. Now let's add something. Let's say we are also interested in the range. What is the range of this graph? The range you can see is just from where? Minus infinity to where? To minus 1, close, union, 1 to where? 1 to infinity. All right. Now, this is coming from which formula? There is a formula for finding the range, and this is also true for any, we'll talk more about it later. Yes, this is going to be from absolute value, right? And then I think this one, then you can have plus C if you have a C, but if you don't have a C, then like in this case, there is no C, so this formula will do the job. All right, so this is how to sketch the graph. Now, this is the range. So let's talk about the domain also here. What will be the domain? The domain is going to be the whole R, so it's going to be minus infinity. Then always remove the what? The vertical asymptotes. So you have to remove the vertical asymptotes in this case. So that is how to find the domain. It's just going to be the whole R minus the vertical asymptotes. And what is the vertical asymptote? If you look here carefully, this is the graph of what's the vertical asymptote is going to be the zeros of the the denominator. So this, when I say the zeros of denominator, it means you need to let sine x plus pi over 2 to be equals to what? 0. And this means that x plus pi over 2 is equals to what? N pi, right? So from here we have x is, you can say n pi minus what? Pi over 2. And you can let n to be integer. We'll talk more about this later. So this is simply saying minus infinity minus the vertical asymptote. This is the general formula for the vertical asymptote, which will be n pi minus pi over 2 whenever n is in integer. Right. So I think that will be okay for now. In the next video, we'll look at examples where we have both horizontal shifts and vertical shift. Thank you for watching.